Today we're going to talk about square roots and the definition of identifying square roots or perfect squares. And we're going to do several examples throughout this lesson to give you a concept of what it is. So first thing that we're going to discuss is, what is a square root? Well, let's look at the number 25. Okay. If you take the square root of 25 is a perfect square, okay? Because 5 squared, or 5 times 5, does in fact give me 25. So a number times itself is a perfect square. So essentially, anytime you have a number, a real number that's times itself, you're going to get a perfect square. Okay, so what we have is 49. Okay, look at 49. And 49 is a perfect square because we have 7 squared, or 7 times 7. Okay. Also, if you have 0, okay, 0 is a perfect square because you have 0 squared, or 0 times 0. Okay. So anything times itself, that will give you that product. Those two factors are essentially two numbers, two identical factors that multiply by each other will give you a product, and that product is a perfect square. Okay. Look at another one. Okay, so if I say to you, what is the square root of 64? Okay, well, square root of 64 is in fact 8. Okay, because 8 times 8 is 64. Okay, so if you take, and to check it, if you take 8 squared and then you multiply it by itself, right, we're going to get 64. We get the product, which is 64. So 64 is a perfect square. Okay. Look at another one, square root of 16. Okay. Again, square root of 16 is 4 because 4 squared is equal to 4 times 4. And when you do 4 times 4, you get 16. So you can almost check every one of these by working backwards, by saying, okay, what times what gives me that number, or what times itself gives me that number. So 4 times itself gives you 16. 16 is a perfect square. Okay, square root of 1 is 1, because 1 squared is equal to 1 times 1. Okay, so all of these are perfect squares. Okay, you can even look at the fractions. For example, square root of 4 over 9 is equal to square root of 4 divided by the square root of 9. If you take the square root of 4, we're going to get 2. You take the square root of 9, you get 3. Okay, so 4/9 is a perfect square. Okay, also works with decimals as well. Okay, and that equals 0.2. Okay. Okay, and the reason, because we have 0.2 times 0.2 will in fact give me 0.04. All right, so as long as you're timesing that quantity by itself, you should get the perfect square right back. So let's do another fraction. Okay, let's see, square root of 36 over 49. Again, let's write them as separate radicals. And go ahead and take the square root of the numerator and denominator. Well, 36 is a perfect square. because 6 times 6 gives me 36. So the square root of 36 is 6. Square root of 49 is 7. Okay? So you can actually do this with not only with whole numbers, but you can do it with decimals. All right, decimals can be perfect squares, and so are fractions. So don't always look at this as just whole numbers. Look at the whole spectrum of numbers, real numbers, and it does work for that. Okay. Now, this is not going to work with the square root of 13, because the square root of 13, there's no number times itself to give me 13, okay, other than 1 and 13. So if you attempt to take the square root of 13, on the calculator, you're going to get approximately 3.60, 5551275. Okay? That's definitely an irrational number. Well, you can approximate it into a rational number, but this does not give you a whole number. No number times itself to give me 13, even if it's a decimal. There's no, this decimal is going to continue. Okay, so unfortunately, we will not be able to do that with square root of 13. And the same thing with square root of 42 is another example. Square root of 3, square root of 5, square root of 7. Okay, they cannot be expressed as fractions. So those will not be perfect squares. Okay. We can also look at negative numbers. Okay, so let's say we had square root of negative 144. Well, we know 12 times 12 is 144, but look at the sign in the radical, that's a negative. Can you think of two numbers that will multiply to give me negative 144? Well, remember, a negative times a negative is a positive number, right? So if I do 12 times 12, you're going to get positive 144. Okay, if I do negative 12 times positive 12, okay, even though you have this, 12 times 12 is 144, but a negative times a positive, yeah, it gives you the negative, but remember, if you attempt to take the square root of any negative number on your calculator, you will get an error message. So that tells me that it's not a real number. Okay? So, therefore, this is going to be not a real number. It's imaginary. Okay? If you attempt to simplify this, you would have to pull out the negative and substitute that with I. So that would be a whole nother lesson. Okay? So this here is just not a real number. Okay? But what if I gave you this? What if I give you negative times the square root of 144? Well, look at what's inside the radical, because that's what's important. The negative is on the outside of the radical. So that's fine, as long as we can take the square root of a number, okay? Positive number, we should be able to get an answer, okay? So if you look at it, all right, the negative is basically on the outside of the radical, okay? But 12 times 12, in fact, gives me 144. And we know that because we were able to take the square root of 144. And when you do that, okay, you should get an answer of negative 12. Okay? Because square root of 144 is 12, and then you keep the negative on the outside. So essentially what I'm doing is basically taking the square root of 144, which is 12, and then just bring down the negative, and then that would be your answer for that problem. Okay? This is just telling me that 12 times 12 is 144, but the answer is negative 12. Okay? Same thing here. Again, you can have a decimal, but if you attempt to take the square root of that number, which is still negative inside the radical, again, you're still going to get an error message. So the answer is not a real number. We will not do imaginary numbers in this lesson because that is another lesson. I'm just going to focus on whether you can take the square root or not of a positive or a negative number. Okay? Let's look at another example. Let's say you had square root of 1 over 9 with a negative on the outside. Well, that equals, again, you have a negative 1 times square root of 1 over 9. Okay? The negative is on the outside, so it doesn't have any impact on the square root of what's inside, which is 1 over 9. So if you go ahead and simplify that, negative 1 times, now remember, square root of 1 and square root of 9, you can write that as two separate radicals. And if you simplify that, the square root of 1 is 1, and the square root of 9 is 3. And then 1 times 1/3 is still 1/3, and a negative times a positive is still a negative. So this would be your final answer for that. Okay? Let's do another one more. Okay? Can I take the square root of that? No, because if I do, I will get an error message. So therefore, not a real number. Okay? You can also use the symbol for real number as that as well. Okay? You can do the same up here. And that concludes this little mini lesson in regards to finding square roots of numbers.